All right, everyone, I'm going to get started. Thanks, everyone, for joining today. I appreciate it. There may be others joining, but thanks, everyone. Today is really the CO2 session I wanted to do today is centered around products. We talked about the basics, if you will, or introduction to CO2 systems and architectures and so on. The last session, which was April 13th, and this session was kind of directed more towards products available here in North America. So that's what I want to spend some time doing today. We've got 90 minutes, a lot of content. If you have any questions, of course, unmute yourself and fire away, and we'll try to answer those as best I can. I see there's other trainers on the line and others that have experience with CO2. So if I can't answer it, then please feel free to jump in. So I'd appreciate that. So I'm going to start off grounding us on the architecture before I get into individual products. I think it's important. Some of you may know it'll be repetition, but I apologize if it is. But if you take a look at the list on the right-hand side, and you go through that list, transcritical compressors, subcritical compressors, compressor VFDs that are coming this year. We've been using control techniques to this date. Condenser motor VFDs, capacity control digital on the low temp side, oil level, core sense, those types of products, high pressure valves and bypass controllers, high pressure valves that can be used for heat reclaim, electronic valves, case controls, system protectors, transducers, pressure controls, high pressure controls, which is really needed as well, leak detection, active and passive, and power monitoring and remote monitoring. I mean, you take a look at that and you compare against our competitors in only the compression space or competitors in only in the control space, and you can see that Emerson really has a wide array of products that span controls, compression, and valves. So that's important to note if you hadn't realized that before. So during the last session, I didn't get a chance to walk through this chart piece by piece because we ran out of time, so I apologize for that. So I kind of want to animate what's going on when you start building out a transcritical booster system. I'm going to focus today on transcritical booster and the products that are used in that. They can be used on a booster. They can also be used in a subcritical side of the system, most of the stuff, and I'll talk about that. So your transcritical compressors, number one, discharging high pressure into a gas cooler. And you can see on the right the impact of that high pressure. On a hot day, you're going to be passing that transcritical mode or into the supercritical phase of the fluid on a hot day, above 88.8 degrees. Now it goes through the gas cooler on a hot day like I'm showing on the right. It still comes out as a gas. It's just de-superheated that gas from about 240 degrees Fahrenheit here to somewhere around 100 degrees Fahrenheit. So it took 140 degrees of sensible heat out of it, but it still remains a gas. And the only way to get that gas to turn into a liquid is to drop its pressure enough so that you can hit the saturated liquid line and liquid starts falling out. And that's what this valve between 3 and 4 on the left is there for. It's an electronic expansion valve specifically designed for high pressures. It reduces the pressure from 3 to 4, and in doing so, liquid falls out. When you're inside the pressure enthalpy dome here, you've got on the right 100% vapor, on the left 100% liquid. So when you fall in the middle, you know right away you've got a percentage of gas, you've got a percentage of liquid. And that's what happens in the flash tank. You've got liquid in the bottom, you've got flash gas or gas on top of that liquid, like any liquid vapor interface would have. that liquid now gets fed to all of your medium temp electronic valves. If you've got 20 cases or you've got 75 cases, it doesn't matter. And then it feeds all your low temp cases. From 5, the pressure is all the same. And then it goes through the expansion valve to a medium temp, and medium temp goes off to a suction area. Again, the liquid at 5 goes to a low temp valve, drops possibly from 500 or 600 pounds down to maybe 200 pounds of pressure, large pressure drop. Up here, you've got another area from 4 to 5. The only way, what we want to do is try to maintain a constant pressure in this tank all the time. And let's say that's 550 pounds. Well, if my head pressure up here, my condensing keeps going up and down because of ambient, that'll have an impact on the flash tank. So this valve, bypass valve, opens and closes. It modulates from open to close to bleed off excess pressure in this flash tank to maintain a constant, or try to maintain a constant pressure in that tank. If the pressure is constant, the saturated temperature will be constant, and then your liquid quality going to all your valves will be constant. So this valve is continuously modulating in order to maintain pressure. But when it does that, it's bypassing that load into the low side. So when we take a look over here between 4 and 9, on the left, 4 and 9 is bypass gas. When you go to the enthalpy diagram, 4 to 9, you've got vapor there. When you're injecting vapor from point 9, you're dropping its pressure down to a medium temp saturated point. Actually, there is a saturation there because it falls right inside the dome. So there's still a little bit of liquid left in that vapor, which used for de-superheating a little bit. So that's an advantage. Down here, as the pressure goes through the low temp evaporator at maybe 200 pounds or minus 20, you go to the right chart from 8, it goes through the evaporator, it picks up superheat until it gets to the saturated vapor, picks up heat, until it gets to the saturated vapor line. Then it needs to pick up an additional 36 degrees of superheat, Fahrenheit, on low temp, but we'll talk about that later. But what happens after that, it goes to your low temp compressor. Low temp compressors now discharge into the suction line. On the left, compression ratio, increased compression, it gets to 12 discharge into the medium temp suction, and that medium temp suction automatically starts de-superheating that gas. It de-superheats it because it's got a mixture of medium temp suction, it's got a mixture of bypass mass flow, which has a little bit of liquid left in it, and that de-superheats the gas before it gets to our medium temp compressors. So that's kind of the stage, and it just keeps moving around and around in that same fashion. So that's the basic architecture. Emerson has a lot of tools, online tools and apps that we can refer to. If you haven't already done so, I know that many of you on the line that I've recognized are using these tools on a regular basis, but if you're not familiar with them, I just wanted to touch base. There's one called CO2 information tool, and I've talked a little bit about that in the past. Let me go to, if you go to the Emerson site, there's a CO2 landing page, and at the bottom, you click on the icon here, and that'll bring up this, excuse me. Okay, I lost my page. I'll click on that. We'll see if it'll bring it up. I was having difficulty a little earlier, but here you go. So what you've got here, you've got a search by category, or you've got a keyword search. And you've got to be careful. There's a North American version and a European. So if you hit Europe, you bring up all the nomenclature from Europe, which is different from that in North America. So you need to be careful. Not only that, Europe have more products than we do in North America because we need UL approval. So if we don't have UL approval on a specific product that is released in Europe, we're not going to add it to the North American selection charts. So if I click on here and I hit compression and I hit find compatible parts, we've sorted it so you don't have to page through page after page. You just scroll down and it shows you all the compressors that are available to date. Even included the largest 28, which is not quite released yet, and we'll talk about that in a few minutes. But as you scroll through here and you want more information on accessories, for example, it'll show you what the suction service valve part numbers are, the aftermarket kit, the type of oil that you need, the crankcase heaters for that specific compressor, the oil level controlled management. So that's shown up in there, and you can go back to the main search and for more results. And you can see that there's compressors, electronic controls, expansion valves, check valves, and so on. And when you click on there, it also gives the default, the maximum working pressure. So you'll know that if a take-apart filter dryer and you click on a take-apart filter dryer, well, it's rated to 680 pounds. So if a customer requires 850 pounds because they're designing a high-pressure standstill pressure system, then you wouldn't be able to use that. But most systems today are still able to use a 680-pound rated product. You need to make sure and double check. So that's kind of a snapshot for what's in there. Product selection software as well has, when you click on the compressor tab, there's compressors up here, and then there's other information down at the bottom, CO2 booster system. When you click on the compressor tab, we've added the larger displacement for MTLs. So you'll be able to find that information now in there, which is good. The 20 and the 22. 28 hasn't quite been added from what I understand, but it will be once it's approved. So also in product selection software, if you click on the booster tab, we're doing a little bit of work with an Aldi's site, and these are actual capacities. For example, 64,000 BTUs on the low temp. You can put in here 260,000 design evaporator load on the medium temp. You put in your temperatures, -21, +21, and all of your various values, and then you'll select the compressors. In this case, we selected a ZO21, a ZOD Digital 58. It showed up to be 128% of the low temp capacity required. Now what happens is this entire total heat of rejection from these selection of compressors automatically gets added down here to the medium temp load so that we can select the right amount of medium temp compressors to not only handle all the medium temp load, but also handle the total heat of rejection from the entire low temp circuit. And by selecting 3 of these 4 MTLS 11s, we're going to be a little bit over at 109% of capacity. And there's a nice little system schematic for customers and even us to see the flow and understand where the mass flow is going. And all the value you inputted in the screen before gets shown up in here. Your gas cooler outlet, your capacity, your pressures, and so on, flash tank, they're all listed here. But a nice feature that the software does, it says your entire refrigerant mass flow in pounds per hour is close to 6,000. But it also shows, hey, at 85-degree gas cooler outlet, you're going to be bypassing 40% of your mass flow into the medium temp to assure the proper flash tank pressure. So you think about that. 40% of your mass flow is being diverted into your medium temp, that these compressors must handle that load without any useful refrigeration happening. It's a price you need to pay with this architecture in order to do that. And I pointed out, because last training session, I talked about high ambient strategies, adiabatic gas cooling, parallel compression, subcooling, liquid and gas ejectors, all of that. That's all done in order to reduce this inefficient bypass of mass flow. That's what all of those strategies are about. If you can reduce this inefficient mass flow bypass, then your entire system becomes more efficient. You add complexity, but you increase efficiency. And that's a key component of understanding why a basic CO2 transcritical system is not that efficient at high ambient. If it was 95 degrees gas cooler out, that would be a higher percentage number. I just wanted to make sure I pointed that out. And the software shows that. Other software, Copeland Mobile, we've talked about this on biweeklies and so on. I'm not showing here a CO2 compressor, but they're in the software. Here's a CO2 compressor example. The newest ZOD58. It gives you basic capacities. If you click on performance, boom, you come down here. It'll give you its performance at a couple of rating points, minus 58 Fahrenheit, which is the very bottom of the envelope, and minus 31, and so on. So information is there in the tools. Application engineering, you can get it in a whole bunch of areas. Apps, OPI, PSS, CPID. There's a lot of ways you can access application engineering bulletins, and they're a great resource, and they have CO2 in there. If you're on the sales, I've showed this before, and Kurt mentioned this on Friday's sales session as well. But we've been testing our own products and our own units now for about 5 years. The first trainer was built 5 years ago. We're on our third generation. The trainer's been so successful with all of our Emerson products that we've sold up to 3 of them now. I think maybe it's even 4 by the end of this year. And those are going out with, you know, as much Emerson components as you see there. So that's good news. They're being operated and used out there. But other OEMs have used our products. Hill Phoenix have used our products. Hussman Systems LNP out of Montreal. Zero Zone's working on some now. Carnot and a number of other OEMs have Heatcraft. So here's examples of some systems. The one on the left is a Sprout store where it's a Hill Phoenix. We're using E2. There was 57 cases in that store. 3 scrolls with a digital and 4 medium temp 4 MTLs. So not a huge store. The one on the right has 7 transcritical compressors. And I was actually in a store where they had 11 on a single rack, 11 4 MTL 15s, so 150,000 BTU nominal capacities, 11 of them, and 4 subcritical scrolls on a rack. So these racks can get fairly large, depending on where you are and depending on the horsepower allowable in whatever region that you're in. So I wanted to start talking about transcritical compressors that we have to offer. It's a design was out of Europe and North Americanized. I say North Americanized because in Europe, if you see a lot of pictures online, you may see a plastic electrical box. And in Europe, they use a plastic and it's kind of rounded shaped electrical box. It's in the same position, but it's just plain a plastic. In the US here, we need a metal box for UL. So that's why you may see a little bit of difference between one image or another. And we've actually released these products in 3 groupings. The middle grouping were the first ones released, called the P1, but it doesn't really matter at this point. But they were the first groupings of compressors to be released. 82,000 BTU, 107,000, and 154,000. That's at a plus 14 saturated suction, which follows the European rates when you convert to Celsius. So 11, 14 to 20 horsepower. The next models that were released here in North America were the 5 to 8 horsepower. So somewhere from 40,000 BTUs to 53,000 BTU. In the third groupings are down here, 24 to 34. The 34 has not yet been launched in North America, but we do have the 24 and the 29 horsepower, so almost 200,000, 230,000 BTUs. The largest displacement here when it's released at 275,000 BTUs, that's at plus 14. When you're at plus 20, it's somewhere around 310,000 BTUs or 25 to 26 tons. So that's nice because on a 1.2 million BTU rack, that's 4 compressors can manage that load. So now we've got something to compete against the higher capacity of Bitzer product. It's not quite to some of Bitzer's, and you'll see in the next couple of slides where other competitors' models lie. As a family of compressors, we've got 9 displacements, as I mentioned, from 40,000 BTUs all the way up to 275,000 BTUs at a plus 14 rating. These models from 40,000 to 154,000, they're actually all the way to 195,000, have a pressure rating of up to 120 bar or 1,740 pounds. That's pretty high. In really high ambient regions, they can actually work pretty close to those ranges. They have pressure reliefs of 135 bar or almost 2,000 pounds. That pressure relief in the front here, 135 bar pressure relief. With the largest displacements, the discharge, the maximum operating pressure is a little bit lower. It's around 1,600 pounds. But the pressure reliefs are all the same. The footprint, doesn't matter if it's a 5 horsepower all the way to a 34 horsepower, the footprint is the same. And the only models that do not have 208, 230 are these 3 largest displacements, okay? Your 195,000 BTU to 275, the 208, 230 volt version is not available. It's 460 or 380, 50 hertz, and 575 for Canada. Well, the compressor comes with a number of features already on it. It comes with CoreSense, but one of the differences between the Discus model CoreSense and the 4MTL model CoreSense is that it already comes standard with the discharge temperature sensor installed and wired into the CoreSense, which the Discus don't. So that's part of the feature there. The valves, you can turn those discharge valves and suction valves 360 degrees, so you've got flexibility there. So that's important. Another thing is that this compressor has a oil flinger, similar to the air-cooled models. If you know our Coplamatic air-cooled models, they have an oil flinger, most of them. And so this one does as well. And because of that, we can have a sight glass on the right side, the left side, and even one up here. And I'll show you the next slide, the value of having a sight glass that high up on the compressor. We have a CoreSense module, and I'll talk a little bit about that. There's a current sensing toroid inside the electrical box. And we have, I mentioned our electrical box is made of metal, rather than this one here. This image shows a plastic rounded version, which is a European image. So here's the terminal box. So if I walk around this compressor, starting from the top right here, we've got the discharge valve. I said 135 bar. And you'll notice on the next slide, I'm saying that originally this compressor also had a suction pressure relief of 90 bar. UL does not require a suction pressure relief installed. And one of the reasons for it, especially with this compressor, is that if the pressure on the low side of the system gets high enough, it can actually make its way into the valve plate and push the discharge reeds up to allow the pressure to escape up the discharge reed. Because this entire compressor has been burst pressure tested to 10,000 pounds. Now, the oil collector I talked about, the sight glass is nice and high because this flinger, the yellow blade here, if you will, as this compressor is turning at 1750 RPM, is splashing oil up, falls into this collector, and the collector is allowing oil to get transferred through the compressor. So you can put a oil level regulator, electronic oil regulator on either of the low oil sight glasses. Another feature of the 4MTL is it's got a balanced crankshaft. So you can see the green counterweight on the back end, the motor end, and the blue counterweight on the crank end. And that's unique to the CO2 transcritical compressor. And I didn't have one here, but when you compare vibration, even in sound, of our compressor versus Bitzer, it has a lower vibration rate, it has lower sound. And as a matter of fact, we had an end user attend our training seminar. He was standing right next to the compressor when it was working. It was a 5 horsepower compressor. And he turned to, I think it was Scott Aveni, and he said, man, I can't believe how quiet this Copeland is compared to the Bitzers I have. So it was noticeably quiet. So it was great for him to kind of notice that and mention it. So I just wanted to talk about that. I mentioned earlier that initially we had a 66 bar pressure relief valve on the low side. It's no longer, if the customer wants a low side pressure relief valve, we have a 90 bar valve available now, but it comes shipped to us without a pressure relief. That hole is capped from the factory for a while now, almost 4 years. CoreSense, you're familiar with CoreSense? One thing though, the models, the 40,000 BTU up to 150,000 BTU, this number one, insufficient oil pressure is deactivated because there's no oil pump in the models from 40,000 BTU to 150. The three largest displacements do have an oil pump, so it will be enabled for the three largest displacements. Competitive from a transcritical compressor perspective, let's not forget, these are our medium temp transcritical compressors. The blue is Emerson down here. And our displacements, I've already gone through them, but when you overlay Dore out of Italy, they have a lot more displacement models on the low end, but they also, in the last few years, have developed larger, much larger displacement compressors to go after that light industrial market. And then Bitzer's in green. So Bitzer have a displacement a little bit smaller than ours. And then you'll see from a slide coming up, the next slide, they have a lot more models available and motor sizes available than we do at this point. But is it relevant to refrigeration? We'll have a big look. And then another competitor on a global scale is Bach and Frasco. So if we look at Bitzer only, forget the others I just showed you. Bitzer's all in green, Emerson's all in blue. The light green is the standard refrigeration motor version that Bitzer uses. The dark green is a heat pump version, which has a different motor. So right away, they double the sizes because they've got two motors. So keep that in mind. There's another thing. They do have a model as well that has a variable speed component built right onto the compressor, similar to our small little recips, the little Embracos. The drive's already on there kind of thing. So they have that. But you can see the blue lines kind of cover the capacity pretty well throughout the range when we compare Bitzer's capacity profile to Emerson's. You can see down there at the bottom, they do go a little bit further out because they've developed a 6-cylinder product in the last few years. So that's why they push that capacity a little bit further out and are gaining some of those industrial jobs while we still haven't launched our largest displacement. Once we do launch a largest displacement, it'll give us the ability to quote against them. Now, a lot of lines on here. Got it. Let me explain what they are. Dark blue line here is Emerson. The smallest capacity displacements from 40 to 64,000 BTUs. The light blue is Emerson up to 110,000 BTUs. Now, the light green in the middle here, that's Bitzer's motor 1 operating envelope. And the dark green is Bitzer's motor 2 operating envelope. Now, let's put it into context. Motor 2 operating envelope is not used in refrigeration. It's used for heat pump, or it's used in areas where it is so bloody hot that it's running extremely high all the time. Not very efficient, but it is what it is. But the refrigeration motor is number 1. And when you compare the envelope of their motor versus our light blue envelope, you can see that A, our pressures go higher, our head pressures go higher, and B, our saturated suction goes much further. So don't let anybody tell you that the operating envelope of Emerson doesn't meet specification for refrigeration. That is not true. And if you forget that and you don't have this slide, we'll send it to you anyway, but reach out to myself or anybody else within the technical team to make sure that you get the right information. Thomas, Chrysler, and others. So that's super important. Now, why is this envelope a little bit different? Well, as you get into larger displacement compressors, even the Emerson envelope changes a bit. So the 150,000 BTU model, the 4MTL15 ME is the dark blue, goes up to 120 bar or 1,740 pounds. But the 3 largest displacements, they're down here at around 110 bar. Again, compared to Bitzer's number 1 motor, we're higher in head pressure, we're higher in saturated suction. And the red dot is pretty much its normal operating range of a refrigeration medium temp application. It goes up and down, of course, based on ambient temperatures. But there you have it. The operating envelope changes. Comparison. Any questions on the transcritical compressors? You'll have to unmute yourself, but if you have any questions, please let me know before I move on to subcritical. You can always send me an email. If you have a question, write them down, send me an email if that's more efficient, and then I will answer them as best as I can or try to get the right answer for you. So let's move on to subcritical CO2 compressors. There's 2 types that Emerson has. We have the Zeo Scroll, which we've got 11 years of experience with. This Zeo Scroll was UL approved back in 2009. And I know that because I used that compressor to build a sample with the Refrigeration Union in Toronto back in 2009, 2010. So we've got a considerable amount of experience with that product. It was basically taking the 410A scroll embodiment and making it CO2 ready, because the pressures of subcritical CO2 down here are pretty close to the pressures of 410A. And if you deal in 410A pressures on the air conditioning side, then you know that they can run up to 479 pounds at 130-degree condensing, which is about your discharge pressures of CO2 low temp. Now, so let's scroll. We also have some 4MTL versions that have a optimized motor that can also work in this low temp subcritical range. And again, pardon me. And again, we're referring to this as subcritical application because we're always below that 87.8 degree critical point, always. It's operating here in this particular example at a condensing of about 23 degrees, pretty low. So compression ratios are also very low. So again, when we overlay our competitors, you can see here the application. We're talking about subcritical now. I mentioned we have two types of compressors. The scroll from a 21,000 nominal BTU, the ZO21, up to a ZO104. Those are the two ranges. And then on the 4MTL semi-hermetic line, we're down here in just under somewhere around the 34,000 BTU, 38,000 BTU, up here to, I think it's 85,000. I'll have to double check on the next slide. 130,000. Okay. Our competitors, Dore, again, they've got a flurry of models, more small displacement. Now, what's important here is I put a 30 bar rating, so that's pretty much the standstill pressure of this product, or its operating range, a little bit over that actually, and from an operating perspective. And then you've got Dore 36 bar rated, but they also have a higher rated. Bitzer has a 30 bar model. They also have a 100 bar model. Brock and Frasco, they only have the lower pressure model. So one of the stresses that we have sometimes is that this 21 is just a little bit too big, because if you have a small store, they've got night curtains, there's no load at night, even that ZO21 is too much capacity. So you get a little bit of cycling going on with that compressor. That's why our competitors do have some smaller displacement models to handle those smaller loads. And not just from a supermarket perspective, but the refrigeration architectures in transcritical and subcritical are becoming smaller and smaller capacities as customers try to move closer and closer to a all-natural refrigeration solution. So that's another thing. I don't have a slide in here, and I apologize for not putting it in. I completely slipped my mind. But we are developing a ZO with variable capacity that'll be able to drop down into a lower capacity range at some point in the future. That's number one. We're also looking at going from a 30 bar to a 60 bar. That's number two. So that's in development pipeline now. That's going to help us achieve both of those. It's a high standstill pressure system. So, you either want a low side, low temp pressure relief blowing off if the system's off for an hour for whatever reason. So what they'll do is they'll design the whole system for much higher standstill pressure, the piping, the evaporators, everything. So if, let's say, it's a 90 bar standstill, which is 90 bar is, I forget the pressure, I think it's 1,305 pounds, then your pressure release would be at 1,305. That means your compressor needs to be able to handle it, as well as your suction piping and your evaporator. And some designers are doing that so that they don't have to add extra mitigation to the system to make sure that the pressures don't exceed the pressure relief values. And you see more of that in industrial, but commercial is starting to move that way as well. Higher standstill pressures are being looked at. And here's one way to do it. So the only 3 models currently approved in North America for low temp use is these 3 models that are highlighted. For MSL, so instead of a T, we put the letter S for subcritical, 65,000, and 85,000, and 130,000. Actually, we've sold quite a few of these 130,000 going into some light industrial applications, some of which are built or designed, and others are for applications by other individual companies. But when you look at the operating envelope here, you can go down to -58 Fahrenheit. Like the Zeo scroll, can go as high as about 32, but your envelope gets narrowed here when you do that because you don't have a lot of head pressure left. So you're good for up to 870 pounds or 60 bar on the head pressure. This is a typical operating point, -20 and about 35. That's a 35 degree, 35 bar, which is about almost 35 degrees with CO2. So the scroll themselves, like I mentioned, first UL model was approved in 2009, been around, leveraging the shell of our 410A product line because they operate around the same pressures. From a nominal horsepower perspective, 1 to 6 horsepower, and we have 3 digital models, the 34, the 58, and the 104. And again, these capacities that we're showing here are at a -31 Fahrenheit and 14 degree condensing with a 14 degree liquid. So to give you an idea, look how high the EERs are. The EERs are very high because compression ratios are quite low on CO2 compressors. So that gets factored into the overall system COP. So we know it's digital. Don't have to explain too much about that capacity modulation. What's interesting, the high side maximum pressure is 43 bar because that top shell is a different, thicker than the rest of the body, can handle higher pressures. And then the maximum standstill pressure for the suction shell is about 28 bar. You got an oil fill and drain, sight glass, and obviously it's a small footprint, and it has the reliability of our scroll. From an operating envelope perspective, it sits right in here. The normal operating, it could be even lower in here depending on the condensing temperature, but somewhere in there. It can go all the way down to -58 Fahrenheit with a head pressure of about 14 degrees and so on. So you follow that line. Compared to the Bitzer Motor 1 version, their Motor 1 version has a greater, wider operating envelope, and then their Motor 2 is even wider, of course. The Emerson one, the 4 MSL that I just showed you, our semi-hermetic version, has a much wider operating envelope than the scroll. But again, you need to ask yourself, where are you operating? Do I fit within the operating parameters of that system? And in refrigeration, you're always within that range. If sound is an issue, the Europeans have a sound blanket that you can use for fixed capacity, and there's digital ones as well. These models have internal pressure relief valves, so if the differential in discharge to suction exceeds X amount of pressure, that internal pressure relief valve will open and allow the pressure to be relieved internal to the shell and on top of the motor overload to turn the compressor off as a protection. If you're using digital, you have built-in core sense or, protection built in. The core sense, the IDCM module has core sense like protection. So if a customer wants to continue with that, that's great. You've got a digital, but the fixed capacity models don't. So you can add a panel core sense to that model. So just keep that in mind if you want total compressor protection from transcritical to subcritical. Panel core sense is definitely available for you to do that, to add that on. This was actually a job I was at in the Woolworths store in Sydney, Australia, where you've got 4 subcritical scrolls. They were all Zeal 34s, but one of them was a digital. And we kind of tracked the suction pressure here until the day that it started. And like all digital, if you can increase your suction pressure, you reduce compression ratios, and there's an energy saving component and a stabilization of suction pressures for temperature control as well. So same concept applies to CO2 as would even an HFC rack as far as digital is concerned. The last thing on the compression I wanted to point out is super important that superheat at the inlet of a low temp compressor must be 36 degrees or even higher. You say, wow, that seems excessive. Well, the medium temp compressors are 20 degrees. And the low temp are 36 degrees. And I'm talking Fahrenheit now. And there's a reason for that. CO2's properties are a little bit different than your normal HFC. And I know we're Copeland people, we've always said, hey, if you got 20 degrees superheat at the inlet of your compressor, you're good to go. And you are for medium temp. This happens to show a cascade system. I apologize, this is a cascade where you've got 134A on the primary and CO2 on the secondary. But my point here is low temp CO2 application, regardless if it's a booster or a cascade system, you need 36 degrees. Because as the evap temperature gets lower and lower, what happens is your refrigerant gets soluble in the oil. So you actually lose oil viscosity if your superheat is low. You got to keep your superheat high to make sure that your oil is in good shape to lubricate all the bearings and thrust surfaces. And there is a chart available. It's a really cool chart. It's a graph that actually shows the drop in viscosity with drop in superheat. So it's important to note that. And you read our literature, you read Doran's literature, you read Bitzer's literature, they all read the same thing. When you do the conversion from Celsius to Fahrenheit, it's 36 degrees for low temp CO2. Any questions on these subcritical scrolls? Again, if you do, you send me an email and we'll try to get those answered. Some of you may or may not know that Zilter, who's really been known to most of the world as a ammonia company, ammonia compressor and skid pack manufacturer, also have CO2 products. We're developing those really. We had a recip product that is we trialed for a few years and moved away from. But now we're focusing more efforts on the transcritical CO2 screw. It's really leveraging a product that was developed for the gas compression space, where you need a high pressure, high capacity compressor to do the job. So we have an existing shell that can handle some high pressures. So the team looked at saying, well, we've got this compressor that's already designed and being sold into gas compression space. And it has an economizer port like these screws do, which we'll talk about in a few minutes. It's got a lot of unique features. Their bearing system, which on ammonia is warranted for 15 years because there's no external thrust. The bearings are completely balanced, which is a really cool feature to have when you're dealing with high pressure systems. So leveraging that technology for CO2 makes a lot of sense. And you take a look here at some of the pressures we're talking about. Now, you may have seen that the transcritical 4-MTL was rated to 1,740 pounds. Well, this was not quite there yet, but we're understanding what can we do with the product we have and what kind of performance can we get with the pressures that are available to us right now. And that's what we're focusing on. And I'll talk about the tests that are going on just briefly, but take a look at the system on the left. That's what's being done today. Industrial or light industrial, and on my bi-weeklies, I've talked about industrial plants. There's one in Texas that has seven racks to do 3.6 megawatts of cooling. A lot of cooling, hundreds of compressors. And, you're taking a refrigeration supermarket mentality and trying to apply it to industrial. That's what's being done today. Because some plants want to move away from ammonia and into another natural refrigerant. And they have to have these multi-parallel compressor racks. Well, what this screw would enable us to do is have one or two for redundancy in parallel. And you can see here on the left, I've got parallel compressors. I'm showing two. So these are extra suction to come into these parallel compressors. Well, this screw model has the economizer port where we could leverage that parallel compression and digest that gas in a intermediate port, like we do with almost our EBI type of scroll type thing. You're bringing in that vapor into a mid pocket. You're digesting it. It helps to cool, but it also provides you some system advantages. So that's kind of cool to look at that from an advantage perspective. A few years ago, we ran across there was a gentleman, a doctor from one of the, a research scientist from one of the large utilities in Canada attended one of our CO2 trainings in Brantford. And we started talking about, I introduced the screw technology. And he started thinking about, wow, that would be really cool if we could use this product for industrial heat pumps and displace fossil fuels. And on the heating side, but also displace HFCs like 134A and centrifugal air conditioning in large buildings. And we started having more and more discussions. We brought in the Vilter team. Wayne Warner, those of you who remember Wayne Warner was involved in these discussions. And then we brought in an OEM of ours, and all of a sudden, we've got a test site. You can see the unit on the left. That's the chiller kind of component, heat exchanger part. Vilter's built a skid pack with a screw on it. The equipment is on site right now. This utility really had to build special floor and supports to handle this large weight. It's been delayed now because of the COVID situation. However, testing, as soon as COVID is, we can get back to operation, we'll start testing this heat pump application because there's a lot of interest in these large commercial buildings, especially the government-owned ones that have greenhouse gas potential reduction targets. So once this unit gets tested at the utilities and it's validated, it already has a home. And once it's validated, there's a potential for 5 more within one building. So we're going to learn a lot on the heat pump side of things, where you can simultaneously heat and cool using CO2, but also learn of the compressor and the skid pack's capability and how can we leverage it to light industrial use in the future. So I just wanted to give you a snapshot of some of the work that's being done that you may not be aware of at all. Really cool stuff, game-changing once we move forward with this. But also the Vilter team has developed some information and packaging on low temperature skids. So minus 40 and plus 20 condensing, 100 tons all the way up to 212 tons. If you're operating at minus 20, 162 tons all the way to 327 tons. So that's significant from a capacity perspective. So just wanted to, again, if you need more information, if you run across somebody looking for industrial, yeah.
How many, who's our competitors for the single screw CO2? Because I know last year or the year before, I've seen a couple other manufacturers. So who else is doing this CO2 with the single screw technology? You know?
I am not. I don't know.
Okay.
I'll have to do some research, but if you got anything, Trevor, let me know, and I'll dig a little deeper. I don't know if Gary Chapey's on the line, if anybody else out there knows, but
I'll find that document I found and I'll send it off. I just want to know who else is pushing for this, and maybe we definitely have the better opportunity right now. So thanks, Andre.
Right. No, I appreciate it. Thanks. So that's one aspect. Another area that the Vilter team has been developing over the last few years is, if you've attended the biweekly, you've probably seen this as well, Vilter Modular Refrigeration Unit. They call it the MRU. And this particular unit can be a combination of CO2 only or glycol, pumping glycol to the evaporators. It could be only ammonia for medium temp. It could be ammonia cascade. So you've got ammonia on the primary, simple cascade chilling CO2, and the CO2 is your low temp CO2 section, and the CO2 is pumped in these evaporators which are attached to the unit, and the air is just blown down into that cooler area, that warehouse area. So it's kind of like a window shaker for industrial refrigeration, if you will. You cut a hole in the roof, and all your refrigeration is contained within the MRU with the gas cooler and or condenser or evaporative condenser sitting on top. So there's variations of this model, but it kind of gives you an idea what the team's been working on and have just recently launched. Okay, it's 11 o'clock. We've got 30 minutes to go through controls, and I think we've got plenty of time here, so that's good. Those of you may or may not, if you were on the WebEx Friday morning, Kurt covered some of this as well. But just to kind of give you an idea that a lot of our products are installed out there. This happened to be an Aldi store in Buffalo, New York that I went to a few years back, where we've got our 4 MTLs. You don't see a sight glass there because it's on the other side of the compressor, 4 MTL. You've got your digital scroll with our OMB oil level control. You got a fixed capacity scroll. We've got our liquid line filter dryer, the STAS, our AOFD, our oil line filter dryer. You've got the Control Techniques drive, high pressure controls down here in the middle. That controls the high pressure, the bypass valve, and here's your valve driver. The brains are in white. The valve driver is on the right. You've got leak detection as well as E2. There's a lot of Emerson stuff on there. It's been operating for the last 5 years at an Aldi store in Buffalo. Most recently, the field service team has been also looking at, they've done a retrofit E2 to site supervisor to see how that would go, and transferring the knowledge of operating a smaller CO2 system with the use of the supervisor. So that's some of the work that's been going on from this field service team out there. But we want to go a little bit further with that, because currently, even though we might have up to 250 of E2s installed with supermarket systems in North America, that's a pretty big number, 250. We can always make it better. And that's what we're trying to do. We're trying to make it better. We're trying to make it easier. We're trying to make it simple to install, commission, and troubleshoot. So the plans are there is to say, hey, there's a lot of really cool stuff going on that Europe has been involved in developing electronic controls for supermarket, CO2, transcritical, because Europe is so far ahead of us when it comes to the application of these systems. They've got over 20, probably 25,000 now systems operating, over 20,000 for sure. So there's a lot of experience there, a lot of people that know what's going on. So what we want to do is say, hey, how do we make it easier for us here in North America, leveraging what they've done, and also including a lot of our lessons learned into the supervisor platform. We're moving away from the E2, we know that. We're moving to the supervisor. So we've got plans under development to try to do that, include some of the lessons that we know in North America work and how they do things here, and also leveraging some of the development that's already been done in Europe. We also have some work on case controls, and I'll talk a little bit about that, from Europe, and the CC200, which is a development project that will be eventually leveraged for CO2, for microbooster, for Walmart, for a whole bunch of customers. So I wanted just to, I put this confidential screen up because these couple of slides came from Excel, and they're not, the graphics that I'm going to show you are not to be shared because they're graphics that are used inside of one of our controls. So keep that in mind. But if you were attending my biweekly, I think a couple of weeks ago, I talked about the new features that Dixell have added to their iPro Rack version. And those features, I'm just going to kind of walk through some of those right now. Kind of a really cool graphic of a simple CO2 system, a basic CO2 system, where you've got your low temp compressors down here, discharging into a de-superheater, that's all that is, whether that's water or air, doesn't matter. Going into medium temp compressors, discharging up to a gas cooler. So right now they can manage with their iPro Rack 12 low temp compressors. They can handle up to 12 medium temp compressors. They can handle adiabatic gas cooling, where you've got adiabatic pads where you drizzle water over top and the condenser or the gas cooler feels like it's a wet bulb temperature, so the head pressures are lower. They can manage that today. They can also manage a bypass, a high pressure valve and bypass valve from a simple system perspective. As you start adding complexity, that's where a lot of complexity goes, whoa, the same basic architecture, same basic system now, we can still handle 12 low temp, 12 medium temp, but now we can have one stage of heat reclaim. And when you come out of that heat reclaim coil, if you want to continue to heat reclaim with something else, then there's a second stage of heat reclaim, whether in series or whether in parallel, it doesn't matter. And then if you have enough condensing going on in series, and this gas is condensed to a liquid or a low enough temperature gas, then it could be diverted to the high pressure valve without even going to the gas cooler. That's one option. Or it can move up to the gas cooler. There's some algorithms to do that. So we can do that with the iPro rack. That's one thing. We can manage parallel compression with the iPro rack. We can also manage what's interesting here, these two other wonky looking valves. And there's also here a suction accumulator. This is, well, normally they don't have a suction accumulator, but with some of these systems, what they're doing now is they're allowing all the medium temp cases. Some OEMs are allowing all these medium temp cases to run at 0-degree superheat. And when you run at 0-degree superheat, your suction pressure can float higher. If your medium temp suction pressure can float higher, that means instead of here having 450 pounds, I might have 475 pounds of suction. That means my compression ratio is lower. That means my motor works less. That means I've got an energy efficiency gain. So by having low superheat, though, I better make sure that I've got an accumulator to trap my liquid. So that's what that's there for. I can gain efficiencies by floating up. I need a suction accumulator to trap my liquid, but once I have liquid in there, I want to try to move that liquid out of there and bring it all the way back into the front of my flash tank. So this is a liquid ejector that takes high pressure gas, siphons or draws the low pressure liquid in, mixes it, and transfers it into the flash tank. And now at the top of this receiver, the suction accumulator, we do the same thing. We're diverting suction pressure away from the compressors and sending it back to my vapor ejector. So it's a strategy. The more mass flow that can be diverted away from my medium temp compressors, the more efficient, they don't have to run, then the more efficient the system becomes. So it's a lot of interconnection, a lot of movements, a lot of algorithms in order to be able to do all that coordination. So the team have been working on that, have launched some systems running. And what I'm saying here is that the team here, Sam Smith and Reggie and others will be working on leveraging what's known in North America, what our customers want, and B, what can we leverage from what's already been done in Europe in the supervisor version. So there's a lot of cool stuff going on, that's for sure. And this particular demo was actually built to have a supervisor. The supervisor is not working in this demo, but we do have at least a first version of a simple system to be able to test new algorithms in. It doesn't have all the bells and whistles that I showed you before, but there's some basic parameters that we can use as far as that goes. And then really the ask is we'll need to find a test site, whether from an OEM, well, it'd have to be an OEM to see how many of these strategies in the supervisor would we be able to test going forward. And that's something, of course, that we'll be working on. And if any of you have some hindsight as to how we could do that going forward, we'd certainly be open to working with you and your customer or on their labs or whatever it happens to be. So I just wanted to throw that out there. From a cooling controls perspective, it was interesting. We had a meeting with one of our customers about a small Aldi store. It doesn't say Aldi on there because I took it off, and they wanted to see what does Emerson have on a typical system available to us. And when we started overlaying all the products on this schematic, it was like, wow, we got a lot of stuff. You start at your Medium temp compressors. Well, we have medium temp compressors, 4 MTLs. Look, those 4 MTL compressors need a mechanical pressure switch. We have that. It's called the CS3. And it's a lot better than the bimetal ones that they were using before. This one is not temperature affected. Some of those cheap bimetal ones that were used in the past, as the discharge temperature started to heat, their set point would change. That was very frustrating for OEMs. So a CS3, I'll show you what that looks like. On the low temp side, pressure switch, low pressure cutout, a PS3, PSC. I think it's more of a PSC now. We have that. Electronic oil level control, the OMC. We have that rated to 130. We have suction filter dryers. The STAS can be used for that. I don't know why I didn't put it on there, but I've got it over here. STAS, 46 bars. Low temp compressors, ZO. OMC, oil level regulator. The PS3 or PSC pressure controls, fixed pressure controls. Some more high pressure pressure controls here. We go up here to my gas cooler. We have a high pressure valve coming off the gas cooler, high pressure valve called a CV valve, a bypass valve called a CV valve. White Rogers developed something called an OLS. It's a optical level switch, and you can use one for high, you can use it for low. That's available. Liquid line filter dryer, STAS, could be installed here as well, coming off the flash tank. I should have written that on there. And then, of course, you've got drives, case controls, E2, high pressure controllers, and we're developing the White Rogers team are developing a North American pulse width modulated, or resurrecting an earlier design of a pulse width modulating valve for CO2 type pressures. So when you overlay all that stuff on this chart, you're going, wow, there really is a lot of stuff that we can offer our customers, a lot more than maybe we had thought of earlier. So it's kind of cool to look at it all in one chart. And these are just some, you'll get this chart that kind of talks about some of the controllers we have specific to some valves. So this is a universal driver specific to these 4 valves. Superheat control specific to these 4 valves. Oil level controls, oil level control, optical oil level sensor. Some pressure transducers. Now there's some, these are the Alco German pressure transducers, but Retail Solutions also has, I'll show you, pressure transducers rated to 2,000 pounds that are currently being used on systems in North America. A high pressure safety switch. Europe have developed an adjustable low pressure safety switch, which is not UL approved yet. So I've indicated that we cannot sell that yet in North America, or a higher pressure solenoid valve, which is not yet UL approved. So there's a few products in there that are not yet UL approved, but many still are. From an oil level control, the OMC is a new device, and I mentioned 130 bars, a high pressure rating, and it even has a maximum operating pressure differential of 1,450 pounds. You may say, well, why would anybody want something so high? Well, if you're using a high pressure oil system, and you can actually go from transcritical pressures all the way down to this device without dropping the pressure. That knocks a component out of the system, like an oil reservoir, which is at a lower pressure. So some users want that. And there's 3 voltages. That's a new feature, 24, 120, and 230 volt. And there's 2 types of models. One has a double sight glass here, so it's easier for viewing from a contractor perspective. And there's another model that just has the 1 sight glass. Just kind of a look at the inside. As a Hall's effect magnet like the OMB has to keep the float from being and jammed up with metal particulates because the magnet is not in the oil space. So that's an advantage, of course. It has a 5-time lockout feature that required for our scrolls. So if it locks out, if it trips 5 times within 30 minutes, there's a lockout feature that forces it to come back and reset, manual reset. So that's kind of a nice feature. There's an ammonia version. The one I'm talking about today is the CO2 version, and kind of talked about all those things. So I'm not going to spend more time on it, but it has the same similar time delay of 10 seconds for low-level signal, and time delay set point recovery is 5, with an alarm time delay of 120 seconds. Those are kind of the standard types of time delays. Don't know if you were aware, but your oil needs to be filtered and dried. And as of late, we haven't talked a lot about this, but they're used on every single system. It may be a small part, but it's an oil line filter dryer that has 100% molecular sieve in the center. It has no activated alumina that can strip acidic POE additives. Additives that we put in oil on purpose. Some of them are a bit acidic for protecting purposes. So you don't want a filter dryer that'll strip the additives out of the oil. So that's why we put 100% molecular sieve for moisture in that. And the outside is a 3-micron filtration, and we need that. So it is rated to 680 pounds, and oil systems, that's generally plenty of pressure for oil systems. OEMs like this because it is a mini pressure control that is not affected by discharge temperature fluctuations. It screws right there close to the on the discharge line as a high pressure safety. That the CS3 is the one up here. Down here, this would be a PSC or a PS3. They look the same, different bellows arrangement for different pressure ranges. So you can see UL approved CS3 up to 130 bar. Over here on the low pressure side, UL approved PS3 or PSC. That White Roger stock's a PSC. I'll show you in a minute. 45 bar. This is designed for CO2, but not yet UL approved. The Europeans have just started selling it. It's basically taking the bellows arrangement from the CS3 and incorporating it into the design of the standard adjustable pressure control. So that's what we've done, but still not UL approved here for North America. So CS3, I talked about that. It's actually 140 bar rated. That's 2,030 pound pressure, maximum working pressure. And there's a micro switch version which has a very tight differential. I thought I had the table here. I apologize. I did not include the table, but they are rated to, they have different models. This particular one here, you can read it pretty well. It cuts out at 106 bar, cuts in at 80 bar. And there's different models available, of course. The temperature range, -40 to 150 degrees Celsius. That's its temperature range. For the low pressure side, so suction, medium temp suction, or subcritical discharge, here's the model, PS3 or PSC. Apologize for the confusion, keep flipping back and forth. You can see the PSC W6S is rated up to 623 pounds. So that's plenty, lots of pressure, even on the low side and the high side. You've got auto reset, manual reset, and with the different freestanding is really what we're looking at here. Freestanding screws onto a Schrader valve. High pressure valves, we've got about 10 minutes, so I'll move along here. The CX valves are there to control high pressure into the flash tank, and as I mentioned earlier, bypass to medium temp suction. And there's a high pressure controller that can drive those. This is the Emerson Pro CO2 high pressure control. There's a family of valves. Emerson has the EX family that's been around for 15 to 20 years. We've been selling them thousands in the last several years. Now that valve has been redesigned to a higher pressure shell. We used to have a valve called the CX. In the last 2 years, it's been redesigned to be called the CV because we've increased the motor torque for CO2. The CV4, the CV5, the CV6 are currently launched. The CV7 is not launched yet. We are trying to get a test site. It's hard to get a test site for that large a capacity because we don't have a test stand that's that large. So that's the challenge that we have right now in the CV7. We have one at the Helix, but it has not been running yet. Now, controllers, Emerson Dixell CO2 high pressure control. For that application, you've got superheat controls. If you're going to use these valves on unit coolers, we have superheat controls that work extremely well. And if you're going to use the valve as a hot gas bypass valve, as an EPR valve, as a suction pressure regulator valve, then you need a universal driver. It's kind of a dummy control that takes an analog in and drives a valve based on that analog signal. And this is really what we're talking about. It takes a 4 to 20 analog in or a 0 to 10 volt. And you could do any application, hot gas bypass, hot gas reclaim, heat reclaim by managing different valves and so on. From a high pressure control perspective, when you compare our valves to Danfoss, which has really been the market leader, Danfoss, and then you've got Corel is another one. Sporlan's developed a valve. So many OEMs have developed valves through the years. Most popular has been the ICMTS and now the new CCMT valve. The 4, 5, and 6 valves that are currently launched with a KB factor of 1.57 gives us capacity equivalent to Danfoss all the way up from the 2 all the way to the 16. The larger version, CV7, that has not launched yet, would cover the remaining 3 Danfoss capacities. Now, let me back up 2 slides, I'm sorry. I grayed out these valves in the middle, the 4.5, the 5.5, and the 6.5. Those are valves that are being added. They're intermediate valves that are being added to the product line to fill the gaps against Danfoss and others. And I show this picture because this happens to be an application where we're using CX valves for heat reclaim. So this real OEM have a discharge, CO2 discharge gas header that goes through a valve, and when they needed heat at a part of the supermarket, they would send this right up into the ventilation. There was a heating coil there with direct CO2, and that's what another application for the CX valves. We do have pulse width modulated valve out of Europe. It's not used that much. So the North American team, White Rogers, is working on another pulse width modulated valve, which we designed years ago. And they're working on quieting the valve. One of the things with pulse width modulated valves is as these valves modulate up and down, like you see here, 1 pulse per period of 20 seconds or 10-second period, there's sometimes a clicking noise that's annoying to customers. So White Rogers team is trying to dampen that noise when it opens and possibly resurrect the new PMM. So there's a project underway with that for North America. Our competitor mainly is Danfoss, where they have about 50 million cycles in their valve. and their valve is serviceable, whereas our current valve in Europe is not serviceable. It's hermetic. Oil level optical switch rated to 1,000 pounds working pressure. So if this thing sits on a flash tank that's sitting at 500 to 650 pounds, you got plenty of pressure. You can see here on the picture, we've got it sitting here on a low level, but it can be installed anywhere. It's stainless steel. Like I said, it's a 1,000-pound rating and available in different voltages, normally closed and normally open for high and low level. You've got pressure transducers from CPC, retail solutions up to 2,000 pounds that we're already selling, filter dryers, and high moisture cores for 46 bar. So for liquid line use, 680 pounds. And our sight glasses are rated to 680 pounds. One thing about CO2, it uses POE oil. And it's important to note that in POE oil, you don't want to get any more than 75 parts per million of moisture in that oil, or you can start to get acid formation. So it's super important to understand that your refrigerant is kept dry at all times. And this cobalt salt element that's used in this element, in this sight glass, the one in North America as well as the one in Europe, has been around for 30 years and is still the most sensitive element in the industry. And we have a chart that can tell you what the temperature of the liquid, the color, what the parts per million of moisture is in that system. And solenoid valves, rated to 680 pounds. Europe's working on a 130 bar valve where they're going to put K65 ferrous percentage in the copper, ferrous oxide mix, the copper mix, I mean, to get higher pressures, but still not UL. The check valves, we have ball valves, and we also have check valves. Be careful when you're looking at check valves. The smallest one, the quarter inch and the 3/8 are 800 pounds, but all the rest are 680. So just don't assume that they're all 800 pounds. So that's important to understand. So it's 11:29. I guess if you have any questions, I apologize. We ran out of time like I often do. But if you have any questions, please feel free to send them to me, and I'll try to get you an answer as best I can. And I'll send you the recording as well as the PDF of this presentation. And if you need actual PowerPoints, let me know, and I'll be able to forward to you that as well. All right? Have a great day, everyone. Thanks for joining. Appreciate it. Bye-bye.